The voltage between the plates of a discharging capacitor can be modelled by the function V of t is 14e to the kt, where V is the voltage in volts, t is the time in seconds, and k is a constant. It was observed that after 3 minutes the voltage between the plates had decreased to 0.6 volts, and that's going to become important somewhere in the question. State the initial voltage between the plates. Well, initial means t equals 0. So that's just going to be, so if t is 0, this is e to the 0, so it's just going to be 14 volts. Determine the value of k. Now that's where this is going to come in, I think. So t is the time in seconds, so 3 minutes is going to be 180 seconds. So we're going to say that 0.6, which is the volts, is going to be 14 multiplied by e to the 180k. So we can solve for that. So let's just clear everything that I've got here at the moment. So action advanced solve. 0.6 is equal to 14 multiplied by e to the 180x. It just says 18, so you need to be careful. Always watch what you're typing in. So let's solve that. Then we get k is equal to negative 0.0175. How long did it take for the initial voltage to halve? So the initial voltage was 14, so that's going to be 7 is equal to 14 multiplied by e, and now we know k, so that's negative 0.0175 t. So we're doing another solve. So 7 is 14 times. So here I'm just going to replace that 180 with negative 0.0175. I could use more of the value if I need to. And that gives me 39.6 seconds. At what rate was the voltage decreasing at the instant it reached 8 volts? Well, first of all, we need to know when it reached 8 volts. So we can solve again for t. So all I need to do there is just change the 7 to 8. So that's 31.98 seconds, should we say. Now rate means we need to differentiate. So we have V is equal to 14 e to the negative 0.0175 t. So dV dt would be 14 e to the negative 0.0175 t multiplied by negative 0.0175. So that's going to be, so 14 multiplied by that, negative 0.245 e to the negative 0.0175 t. So we want dv dt evaluated when t is equal to 31.98. So all we need to do is calculate that. Actually, there's shortcuts to this that I haven't used. Let's just do it. 0.245 multiplied by e to the power of negative 0.0175 times 31.98, and that gives us negative 0.140. And so that's a 0.140 volts per second decrease. Now, if that seems like a lot of work for 2 marks, that's because there is actually a quicker way of doing it. Just think about the fact that V is equal to 14 e to the kt. Let's not worry about the value of k. dv dt is going to be 14k e to the kt, which is actually kv. So dv dt, now let's bring in the value of k, is 0.0175 multiplied by the voltage, which is 8, and you'll find that that gives you the same answer that we had before at negative 0.14.